Tech Nuba presents how to convert decimal to binary and binary to decimal for retro console gamers.
In 2002, the way I trained myself how to convert decimal to binary and binary to decimal for the CompTIA Network Plus certification exam was by associating the generations of console gaming throughout my life with the number of associated bits they were advertised to have. The numbers you have to memorize to do the conversion are as follows: 128, 64, 32, 16, 8, 4, 2, and 1. And so the way I associated these was for 128, I thought of the original Xbox, because we were told that that was a 128-bit console. For 64, I thought of the Nintendo 64. 32 for PlayStation. 16 was the Super Nintendo and Genesis. 8, the original Nintendo. Now the last three are kind of made up. The Atari 2600 I put for 4, even though it's really technically an 8-bit console. Odyssey at 2, and Pong for 1, because Pong is usually referred to as the first gaming console. Even though no one knows really what the first official video game was, Pong is usually called the first one. So Atari, the Magnavox Odyssey, and Pong, while those aren't the real bits of them, I'm able to think of the progression of gaming consoles. So I started with Pong, then I played Odyssey, then I played Atari, then Nintendo, Super Nintendo, Genesis, then PlayStation, Nintendo 64, and then the Xbox. So that's how I was able to memorize the numbers. So when I would write them down, I would just think of all the gaming consoles and just fill it out like that. That's how I could remember the numbers. Now I remember the numbers by heart, just like I had remembered the progression of gaming by heart. And my hope is that this technique of associating gaming generation consoles with each of the bits of the octet will help you memorize this for any sort of conversions you need to do in the event that you don't have a calculator. So we will try 3 exercises to hope to demonstrate these conversion principles and how to do it by hand. Exercise 1. Convert 167 to binary. So the first question we ask is, does 128 fit into 167? If yes, we write down 1. If no, we write down 0. So in this case, the answer is yes, and thus we write down the number 1. After that, we take 167 minus the 128 we put into it, and that'll give us 39. And then we take that 39 and ask, does 64 go into 39? Since the answer is no, we write down 0. And then we perform the calculation again, and we ask, does 32 fit into 39? And that answer is yes, so we write down 1. We perform our subtraction again. 39 minus 32 equals 7. And then we ask, does 16 go into 7? And that answer is no, so we put 0. Now we still have 7, and we ask, does 8 go into 7? And that answer also is 0, or no, so we put 0. And then we ask, does 4 go into 7? And that answer is yes, so we put down 1. And then we do our subtraction. 7 minus 4 equals 3. Does 2 go into 3? Yes, so we put down 1. 3 minus 2 equals 1. And then does 1 go into 1? Yes, so we put down 1 for yes. And our problem is solved. And we are saying that 167, a decimal number, converted to binary, is 101001111. And then to check our work, we could use the built-in calculator in Windows and switch it to programmer mode and type in 167, switch it to binary, and you'll get 101001111. Let's try another exercise. of the same exact type of question, I like to repeat in order to reinforce. Because the first time you see something, if it's the first time you're taking it in, and now this second time, let's see how that information is retained and able to be used in a similar kind of problem. So on this one, we are going to convert 85, which is decimal, to binary. So obviously step one is to set up our numbers. Xbox 128, Nintendo 64, 64-bit, PlayStation 32-bit, Super Nintendo Genesis 16, Nintendo 8, Atari 4, Odyssey 2, Pong 1. Now, first question is 85. Does 128 fit into 85? The answer is no, so we put down 0. And then we don't have to do anything else, and we ask the same question, does 64 fit into 85? And that answer is yes. So we put down 1. Then we take 85 minus 64. That gives you 21. Then we ask, does 32 fit into 21? And that answer is no. So we put down 0. We don't have to subtract anything. Then we get to the next number. And we ask, does 16 fit into 21? And that answer is yes, so we put down 1. And then we say 21 minus 16, and that answer is 5. And then we ask, does 8 go into 5? That answer is no, so we put down 0. We don't have to do any calculations. We then ask, does 4 go into 5? And that answer is yes. So we write down 1. Do our subtraction. 5 minus 4 equals 1. Does 2 fit into 1? No. So we put down 0. And then we have, does 1 go into 1? And that answer is yes. And so we write down 1. And our final answer is 85 in binary is 01010101, which is a pretty cool answer. And then to check it, we could open up our computer calculator, type in 85 for decimal, and click on binary, and it'll convert it to 1010101. Notice there's no 0 at the beginning. It drops, if there's a 0, it drops the 0 and just starts with the first 1. That's why there's only 7 numbers in the calculator answer, but you still need 8 places. Okay, and to wrap up, we will do a final exercise. This one is going to be the opposite. This time we are going to convert a binary number, 11001101, to decimal to find out what decimal number that number represents. So to start, let's set up our numbers, 128, 64, 32, 16, 8, 4, 2, 1. And then we were going to put the numbers for the binary underneath there. So the first number put under 1, 1, 0, 0, 1, 1, 0, 1. You can see how they all line up. And this is a lot easier than the other way. And so once you have everything lined up, that first one is 128. There's a 1 for 64, so you do 128 plus 64. There's nothing for 32, nothing for 16. There's 1 for 8, so plus 8. And then there's a 1 there, so plus 4. There's nothing for 2, so no 0. And then a plus 1. And then we add all those numbers together, and you end up with 205. I went a little fast there, but essentially the numbers, the binary numbers, you'll have 8 of them. If you stick them underneath each of the headers, and then if there's a 1, that means you add them. If there's no 1, you don't add them. They just represent 0. And then you'll end up with your number. In this case, 205. And so to check our work, just to see if this is accurate or not, let's open up our calculator. And this time have it on binary. And notice you'll have zeros and ones. Everything else is grayed out. Type in 11001101. Click on decimal, and it converts to 205. It's pretty neat. This technique works for all the numbers 1 to 255. And if you add all of the numbers in our headers together, you will get 255. So if you added 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that equals 255. If this video was useful to you, like, comment, favorite, and subscribe to Tech Nuba.
Check Nuba.